And last but not least, I want to talk a little bit about standard deviations. I want to clarify something from the mean, median, mode section. When I was talking about taking the average or lining up the observations so you get the middle, things like that, what I was talking about was one variable, right? So we talked about how a data set is composed of many variables. The variables would be like the columns in a spreadsheet. So just to be super, super clear, when you're taking the mean or finding the median or finding the mode, you're not doing the entire like spreadsheet of data. You're just thinking about one column. What is the mean income for my sample? What is the mean high school GPA for my sample? What is the mean number of credits taken, right? Just to be super, super explicit about that. Okay, and let me know if you have questions about that, because I watched the video back and realized that may not have been totally clear. Okay, as I mentioned at the outset of this video, a lot of this is going to be much, much, much more detailed and more explicit in future chapters, so I just want to talk really quickly about standard deviations. What a standard deviation measures is how far from the mean an observation is. So how far above the mean, how far below the mean is a particular observation. So for example, to use the test score example again, if the mean test score is an 80% on whatever test it is that you gave to your students, how far above or below the mean are the rest of the test scores? And I think the book gives really good examples of this. In terms of the more variation within your data, the larger the standard deviation is going to be. The book mentions figure 3.5, which is the stem and leaf plot about crime rates in Canada versus the United States. I know I said I don't like stem and leaf plots, which I don't, but I think that's a really good example of one country having a much larger variation, the United States, in crime rates versus another one. So I think that's a really good example of standard deviations and deviations in the data. So check that out if you haven't already. So really briefly, because we're going to get into this much more concretely in the future, but if your data are what we call normally distributed, and that's what's behind me, if there is symmetrical distribution around the mean, right? We talk about a bell curve or a normal distribution are basically the same thing. Something to think about, and this is going to matter when we start talking about p-values and t-tests and stuff like that in the next couple chapters, is what you, I hope, see behind me, and I hope those colors are clear. So if the data are normally distributed, about 2/3 of your observations should be within one standard deviation of the mean. So that's the orange 68% behind me. So 68%, and that's actually 34 on either side, right? 34% above, 34% below. 68% of your observations should be within one standard deviation of the mean. 95% should be within 2, and 99% should be within 3. If you are seeing data that varies more than that, that's kind of a red flag that you should really dive in a little bit deeper and see why that might be the case. Do you have crazy outliers? Is your data skewed in some way? So it's possible that the data are not normally distributed. They're distributed differently, so you need to think about how to better address some of the calculations and the analysis you're going to do. We're not going to talk about different distributions in this class, but if you are interested, grab a probability textbook and they will talk all about them. It brings back like flashbacks of my my stats degree. But most typically, and throughout this course for sure, we're going to assume that our data are normally distributed. So this is something just to think about when we're thinking about standard deviations. And again, much more to come on this moving forward. The data talks a little bit about percentiles and quartiles. I guess that's kind of used when you talk about testing and income to some extent. Like someone is in the 99th percentile of a test score, someone is in the 99th percentile of income, and what that means is that there's only 1% of people in that sample who are above where their income is. So another example would be like the ACT. Like if you get a 36 on the ACT, you're in like the 90-somethingth percentile, probably 98th percentile, because only 2% of students get a 36 on the ACT. Related to that, we talk about quartiles. It's basically the same thing. It's just 25%, 50% is the mean or the median, and 75% is like the upper bound. So when we talk about quartiles, it's just 25, 50, 75. So same idea, but just quartiles are sometimes a little bit more standard. Not always, though. And the only other thing, real quick, this is again like Emily's preferences. I don't like box plots. I think people find them useful just to kind of play for when they're playing with the data and thinking about what the data looks like. I would not necessarily present box plots in a paper or an analysis, but it can be helpful when you're thinking about quartiles, the interquartile range, as well as percentiles. And I think something that's really, really fundamental that we're going to get into, they mention at the end of this chapter about looking at the association between a dependent and an independent variable. So the dependent variable is what you are trying to determine, right? Like income or success in college or likelihood of doing something. And the independent variable is the variable that is acting on the dependent variable. So for example, what is the role of taking remedial math, which is the independent variable, on graduating from college on time? That's the dependent variable. So they kind of just like go over this very quickly in the book, but the whole crux of what statistics is and what we're trying to do in this course and what we do in statistics like in general is think about these associations and these relationships between dependent and independent variables. How does one act on the other? So when they mention scatter plots, that's actually really useful as well to visualize that association. So I'll stop there. That was basically the end of chapter 3. I think please be in touch if you have any questions. There's also going to be a video about the Murnane and Willett chapter 1, as well as for the following week, for week 3, I'll do a little preview of what we're going to be doing in person together. So I hope everybody has a great week, and please be in touch if I can do anything for you, if you have questions, and I look forward to seeing you all soon. Thanks.